Now let's do some exercises. So the first one, fix the code right here to print 3, 4, 2, 7, and 5, 8. So, in order to know how to do that, we must know what lattice point is, but before we even know and take a look at the class lattice point, we notice that there's some immediate syntax problems. So first of all, we have our elements right here in an array, however they're not separated by commas. So we need that. Because they're elements in an array, it doesn't matter that they're in different lines, they still need to be separated by commas. The next problem is that we declared and initialized an array in a statement, but we don't have a semicolon at the end of the statement. Remember, we need a semicolon at the end of all variable initializations or declarations, even if it's formatted this way. And lastly, one thing you notice is that points is an array, so if I directly print points, it's just going to give this useless thing. Let's not deal with that for now, because we need to first take a look at our lattice point class itself. So right here we have a lattice point class with 2 instance variables of type int, 2 parameters, appears to set the instance variables with the parameters. Now, let's go back here. We have our array of points right here, and then we can't print the array itself, we know that. We also know that we cannot print a lattice point itself either. So we cannot loop through the thing and print the lattice points, it's not going to give any useful information. As you see, if we try doing that, it's just going to give useless information, just like when we tried to directly print the array. So that's not good either. So how do we do this then? Well, one way is to directly print out all the variables. The other way is to make a display method. I'm making a display method so that if I make more lattice points, I can display them like that. And now, all of a sudden, I can call the display method for these. So now let's loop through the array for every lattice point p in points p.display. Now, this is where we run on into our next problem. We get all zeros. And why is that? Well, it turns out over here, our parameter name is the same thing as our instance variable name. And that means that every time we, inside the constructor, whenever we refer to x, we refer to the parameter, not the instance variable. To fix this, we can do this dot x equals x and this dot y equals y. Because logically, x equals x does nothing and y equals y also does nothing. Now, all of a sudden, it prints exactly what I want. The next exercise, fix all errors of this thing. So first, there's a few errors that you should spot immediately. Like for example, when we declare a lattice point variable and initialize it, the constructor requires us to have new. We can't just have a constructor like called like this. That is not allowed. So new, we need that. Next, we notice that we have x right here. That is not allowed because, well, what is x, right? We never defined a variable named x in this class or in the method. It turns out I'm just referring to the x variable here, so you just need to do 0.1 dot x. Next, again, lattice point dot y doesn't make sense. Y is an instance variable, and we can't access it using static context. We need an object in order to access an instance variable. So 0.2 dot y, like that. Now, the next thing is right here. Oh yeah, we also need new. Next thing is a bit more subtle. Basically, we try to print 0.3, but it doesn't let us because 0.3 might not have been initialized. Now, how do I deal with this issue? Because point 3 we know for a fact has been initialized, but Java doesn't because it's inside a for loop that could potentially not execute. So how do we deal with this? Well, there's different ways. One way is to first set it to a dummy point like that, because it doesn't matter anyway. We're going to set it to 5,6 later. And now it works in some sense. At least no compilation errors. Now we're done with all the compilation errors. There are no runtime errors, however, there's problem. Basically, when we try to print point 3, it doesn't work. To fix that, we can just do something like point 3.display. This is technically not an error, but it's good to just fix that. And now we're done. The next exercise, fix all errors of this code. So there's several here. So let's first start with this, system.out.println I. What is I? Well, I is a variable defined inside the loop, and remember, when you define a variable inside of a loop, then the variable disappears outside of the loop. One way to fix that is to just define it outside of the loop first. Of course, then I don't have to redefine it inside the loop, I can just do that. Of course, int I equals 0 is important. If I just do int I, then it might not have been initialized, which is not good. We dealt with that issue. Now, this issue, variable a might not have been initialized. What's the problem here? The problem here is we have a variable a, and we try to multiply it by 2 before it's initialized, or potentially before it's initialized. In this case, actually, we know that in the first iteration it's going to be initialized, but like Java doesn't know that before executing. So to fix that, we can do something like a dummy value like that. And now it compiles. And when we run, it works. The next exercise, determine the output of this. So for this one, so first we have that array 5784 and another array that points to the same thing. So the variable those two variables point to the same array. And now we print array 2. That should be no big surprise. That's just going to be $5,784. Like that. Next, we do for every int in ARR1, I try to multiply it by 2. However, notice that we can't do that. Basically, if we try to multiply by 2, it's just going to not multiply by 2. And for some more logic, let's just look at this. So first, ARR1 points to 5784, and ARR2 also points there. And now for int I in ARR1, so for every int I in the ARR1, so first I equals 5, then I multiply it by 2, and it becomes 10. Because notice that I is not the same thing as this element, it just contains the value of this element. So therefore, multiplying I by 2 does not affect the array. So therefore, when we print array 2 the second time, it's still 5784. Next, we do for every int I from 0 up to ARR1.length minus 1, I try multiplying the element by 2. Now this time, I is 0, then the element ARR1 of I is this, multiply it by 2, I is 1, multiply this by 2, I becomes 2, multiply that by 2, I becomes 3, multiply that by 2, and I becomes 4, the loop ends and I disappears. So now it changes the array. So when I print array 2 the third time, I get that the numbers have doubled, as shown below. Because when I modify the elements of ARR1, I modify ARR2 because they share the same elements. The next exercise, determine the output of this. So we have this two-dimensional array right here. And then so let's keep track of the output. So first, we try setting every element to 7. However, note that, again, same as the logic for the previous problem, just setting the loop variable for each loop isn't going to change the array itself. It's just going to change the loop variable, which is useless. Therefore, when I try printing the array, it's just going to print the array itself. So over here, it's just going to be 579 6 8 7 blank line 13579 and 02468. Then next we go over here, and now for every row in ARR2D, then I set each element to 7. Now, does that change the array itself? It turns out yes. To explain, let's use this diagram again. Now, when I do a for each loop like this, initially I points to this array right here that's part of ARR2D. Therefore, if I modify the elements directly, so I of j, which is different, by the way, than modifying the loop variable. Right here, I'm modifying an element by accessing the array using an index. Therefore, first I modify this one to be 7 because, well, that's what I points to. ARR2D just happens to contain the same thing. That gets set to 7, that gets set to 7. I moves on. That gets set to 7, that gets set to 7. I moves on. That gets set to 7. I moves on. Well, there's nothing to set. I moves on. Sets all of these to 7. Then afterward, I moves on to the last row and sets all of these to 7. Then I disappears after the loop. So then therefore, now it's going to be 777, 777, blank line, 77777, 77777 when I print it, as shown below. The next problem, determine the output of this. Well, first, in order to determine the output, we need to know what these swap methods are. So let's take a look at them. They're right here. So back to here. Let's keep track of the output as well. So first, we have, let's also keep track of the everything. I1 equals 2. I2 equals 4. Then swap 1 of I1 comma I2. What does that do actually? Well, swap 1 right here introduces an I variable that's set to I1, so I is 2. J is 4 in swap 1. Then I equals J, all that does is sets I to 4. I1 is unaffected. J equals I, that just sets J to 4. So I2 is unaffected. So therefore, it doesn't affect the variables in the main method, which is expected. You can't modify int variables in a certain method by calling another method. So then when I print it, it's just going to be 2, 4. The next one, I have these two arrays and I try to swap them. Well, swap 2. So right here, A equals B, B equals A. Well, first AR3 basically points to 57986. AR4 points to 468. When I call swap 2, now A points to ARR3 and B points to ARR4. When I do A equals B, now A points to ARR4, so something like this. And then B equals A, well, B already points to the same array, so that nothing happens. So we have this. Then after the method is done, we notice that A and B disappear. And notice that ARR3 and ARR4 are not affected at all. Primarily because we did the parameter equals. And usually when that happens, that destroys the link between the parameter and the argument passed in. Therefore, when I try to print both arrays, it's going to be 57986, 468. Like that. Afterward, I tried doing swap 3 using ARR3, I1, and I2. So, basically, swap 3, A is just pointing to ARR3, I is set to 2, and J is set to 4. A of I equals A of J. So A of 2, that's that element. Notice it's also an element of ARR3. This time, because we're modifying elements, it works. Or ARR3 of 2 equals ARR3 of 4. So this element is set to that element. Basically, this element is now 6. Then A of J equals A of I. So A of 4 equals A of 2. Well, A of 4 is already A of 2, so that does nothing. Then afterward, I'm done with the method, and I and J are gone, A is gone. So yes, it did modify the array to 576, 86, 468. Also notice that these two methods just straight up don't work. This method modifies the array, but it actually doesn't really perform a swap. As you see, 57986 was changed to 57686 because remember, in order to perform a swap on two variables, you still need a temporary variable. The next exercise, we have this. So let's keep track of the output. And for this one, it's also smart to keep track of the diagram. So first we have ARR1, which points to 1, 2. Then we have ARR2. What does that do? That points to an array that is basically, well, it contains ARR1 and ARR1. Notice that it doesn't contain ARR1 actually, it just has two elements that points to the same array. So basically we have something like, let's just call this element 0, element 1. It's really just row 0 and row 1. And then element 0, just say points to the array, like that. And element 1 also points to the array. Like that. Both of these elements point to the array, so both of these rows are the same array actually. Therefore, so first when I try to print these, this one's relatively straightforward. Basically, it just basically prints the array, so it's just going to be 1, 2, 1, 2. Because first, when I is element 0, it prints 1, 2. When I is element 1, it prints 1, 2. Then ARR1 of 0 equals 3. ARR1 of 0 equals 3. So that's 3. Notice that by the diagram, it also affects element 0 and element 1, which point to the same array, which means it modifies ARR2. So now when I print ARR2, it's going to be 3, 2, 3, 2. And the results are also shown below. And finally, the last exercise. Determine the output of this. Well, in order to do that, we need to know what classes A and B are. So here are the classes A and B. Not a lot. Basically, A contains 2 int variables and a constructor that sets them using parameters. B contains 2 A variables of type A, instance variables, sets them using parameters in the constructor, and has a display method that prints basically A.A, A.B, B.A, B.B. Basically, A.A and A.B is its first instance variable, B.A and B.B is its second instance variable. Now, determine the output of this. So for this one, it's smart to keep track of both the output and the diagram. First, we have A1 that points to, I'm just going to use an ordered pair to represent this. And then A2 points to 3, 4. B1 basically points to, well, I'm going to call this U1 and U2. Basically, it's instance variables. That's what I'm calling them. Actually, it's better to call them B1.A and B1.B. Like that. And now, what do they point to? Well, basically they point to, so something like that. The second one points to A2, so something like that, basically. And B2 is just B1, so something like that. That's our diagram. So when we display them, well, the first one's gonna be 1, 2, A.A, A.B, and then 3, 4. And the second one's gonna be the same because they literally point to the same object. Then we do B1 equals new B A2 comma A1. So now B1 is no longer pointing to this. Instead, it's pointing to a new thing. So B1, new B of A2 comma A1. So actually, let's rename this to B2.A and B2.B for less confusion. It's still the same variables, it's just that B1 no longer. In fact, I could rename these to A and B and be fine, because technically that's what they are. They don't like B2.A. So now B1, it's probably better to put these up here. So B1 points to A comma B. These A and B's are different A's and B's, by the way. And then with A2 and A1, so A points to A2, so basically, and then B points to basically something like that. So now when I do B1.display, it's now 3, 4, 1, 2. When I do B2.display, however, it's still going to be the same, 1, 2, 3, 4, because B2 is not affected. I did B1 equals, so B1 becomes detached to B2. However, notice that their variables just still print to the same objects, just in different orders. Now b1.a equals new a 5 comma 6, so that eliminates the connection between a and that thing. So instead now it's a new a of 5 comma 6. Now b1.display, so basically now it's 5 6 1 2, and then b2.display, well, that's still gonna be 1 2 3 4. Notice that this is, although the second level of deepness, b1 has already detached from b2, so it doesn't matter anymore. And then I print a1.b. Well, a1 is not affected by that, so 2. Then afterward, b1.b.b equals 7. b1.b.b equals 7, so that's changed to 7. Now this affects everything because the int variable itself was changed. So then now this affects b1, it affects b2, and it even affects a1. So b1.display now, it's gonna be 5 6 1 7, and then b2.display is gonna be 1 7 3 4, and then a1.b is gonna be 7. Now output's also shown below. Basically 1 2 3 4 1 2 3 4 3 4 1 2 1 2 3 4 5 6 1 2 1 2 3 4 2 5 6 1 7 1 7 3 4 and 7.